Hello everyone and welcome back to another video provided by SVSU's Online Tutoring. My name is Joel and today we'll be talking about graphs of inverse functions in section 9.2. And so with this topic, we should already be familiar with solving for the inverse function, but I'll just lay out an example real quick. So if we had the function f of x equal to x cubed, how do we go about finding its inverse function? Well, the most simplest way to do that is to let f of x equal y, and this is just for an algebraic representation. And so we have y equal to x cubed, and then what we want to do is that we can switch the placement of the x and y, so that we have x equal to y cubed, and then we just solve for y. And to solve for y, we take the cube root of both sides, or raise it to the power of 1/3, and we get the cube root of x equal to y, which is our inverse function. So therefore, our inverse function over here in black now is equal to the cube root of x. But what exactly does this do these two graphs look like in comparison to one another? So that's what we're going to go over and see for ourselves. So what we can do is that we can create a table. So I'll just write this out. And we'll just keep things defined above 0 or equal to 0. And we'll just go over the first 3 points. So 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, and 3 cubed is 27. And if we're taking the cube root of 0, that is also 0, and if we take the cube root of 1, that's also 1. But the cube root of 2, I have to go in and punch that in my calculator real quick. I don't know it offhand. It's about 1.256. Oh, I'm sorry, not 56. This 5 here is supposed to be a 6. It's approximately 1.26, and then the cube root of 3, let's see, that's about what the square root of 2 is. Kind of close, right? Let me see. Yeah, they're kind of close to one another. Okay, so if we wanted to go ahead and graph that, we can do that over here. We have our y values, and then our x values on our axis here, and then the first 3 points. We got 0, 0 for, oh, okay, so I guess what I can do to color code this, I'll do f of x in red and the inverse function in green. So starting with our red here, we have 0, 0, and we can't forget our little ticks here, so this is 1, this up here can be 8, and then way up here is 27. So you have to remember it's a cube function, so it's going to get large very, very quickly. Then we have 1, 1, and then we have 2, 8, and then we have 3, 27. So then I just have to connect this. Connect the dots here. It's a little off. I always hate when that happens. There, that's better. And then in green, we have 0, 0 again, 1, 0, and this is 2, 1.26, so it's just right barely above. And then fairly higher here as well. So what's going to happen is that the interesting region that we're looking at, if I, hopefully this works, if I zoom in here, let me take a look at my, yeah, okay, cool, is this region right here. So this, it's gonna go something like that, something like this, because in between 0 and 1 here, so we have 0 and 1, we're taking the cube root of decimal numbers, and so when you do that, you actually end up with fairly, well, not fairly large, but just larger numbers that would appear in the cubic function, because they're inverses of one another, right? So if you take 1/2 cubed, you'll get 1/8, which is 1.25. But if you take the cube root, you actually end up with, let's see if that gives us a fraction. No, it doesn't. But you actually end up with a decimal that's approximately 0.7937. So that's the imaginable difference there, and so that's why it actually curves up like that, and then once it hits 1, it begins to plateau real hard. So no real noticeable change, and that's really how you go about graphing inverse functions. We can take a look at a similar one that looks a little bit better than a cube function, and that's x squared. So if we have f of x equal to x squared, then the inverse function is obviously the square root of x. So we have our f of x values, our f inverse values, and then our x's. And if we go from 0, 1, 2, 3 again, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. And the square root of 0 is 0, square root of 1 is 1, square root of 2 is approximately 1.414, and the square root of 3 is approximately, what is it? It's like 1.73, okay? And what we can do is that we can just draw the graph right over here. So draw our axes. We have y, not to be mistaken for an x, and then our x right here. And so again, I'll use the same color scheme as before. Just so we know what color we're talking about. And then make sure to draw my tick marks as well. So we got 1, 2, 3, and then we need to go up to at least 9. So that'll be 1, that'll be 4, and then way up here is 9. And so in red, we plot our f of x. So we have 0, 0, we have 1, 1, 2, 4, and then 3, 9. And we can connect the dots. So we have something like this going on. And then for our inverse, we have 0, 0, 1, 1, 2, 1.4, and then almost half. And then if we connect those dots, so something like that. And as you can see, it's not as drastic as our cubed function, or well, I guess how would you phrase it? Our third root. Yeah. It's not as drastic of a plateau as you go beyond 1. There's still like a little bit of increase that you see going along here. but you still end up with that region where it's where the inverse is slightly larger than the original function, same as there. So, yep, that's how you go about graphing inverse functions. It's exactly how you would think about it. All you have to do is, if you're given an f of x and you have to graph its inverse, is to just solve for the inverse and then create a table and you're good to go. Alright, see you next time.